In Lesson 10.6, we want to concern ourselves with finding angle measures inside on and outside of a circle. So let's reflect and review those concepts that we've talked about so far dealing with angle measures and circles. The first angle that we talked about, special angle, was the central angle. Remember that a central angle has as its vertex the very center of the circle. So if here I have circle P, I know that P is the center. If I put an angle in here, such that the vertex of the angle is also the very center of the circle, then I have a central angle. The measure of a central angle in degrees is the same as the intercepted arc in degrees. Remember that the intercepted arc is the piece of the circle that lies between the two sides of the angle. The second type of angle measure within a circle we talked about was the inscribed angle. An inscribed angle has its vertex on the circle itself. The vertex is on the circle itself. If I want to find the measure of the degrees of that angle is always half the intercepted arc in degrees. And again, our intercepted arc is that piece of the circle that lies between the two sides of the angle. Playing off of the inscribed angle, we have a special type of inscribed angle. We have an angle inscribed not just in the circle, but in the semicircle. So I'm going to put the circle, the center of the circle, and then I'm going to put a diameter in there as well. So let's go through the very center of this circle. We're going to put our center right, whoops. It doesn't want to do that. Okay, let's put our center right there. Okay, so we have here circle, let's just call this circle M. So by naming it circle M, I have no doubt whatsoever that M is the center. If I have an inscribed angle in this semicircle, that means that one end of the angle is going to go out at one edge of the diameter, and the other side of the angle is going to go out the other diameter. So I'm going to come in here and go through there, and then back through there. Now that angle is inscribed in the semicircle. Again, see how it's the sides, one goes through one end of the diameter and one goes through the other end of the diameter. That is inscribed not only in the circle, but more specifically in the semicircle. When I have an angle inscribed in a semicircle like that, its vertex is still on the circle, just like we have over here with the inscribed angle. But since I know that the arc that it intercepts is half of the circle, and half of a circle is 180 degrees, then I know that any angle inscribed in a semicircle is going to be a right angle. We want to add to that another type of angle that has a relationship in the circle, and it's not really an inscribed angle, but we treat it as an inscribed angle. For instance, if I have a secant and a tangent. Okay, this is my tangent. My tangent line touches the circle at one point, and over here I have my secant line. If I have a tangent and a secant that intersect at the point of tangency, then notice that I have two angles formed. I'm going to name them angle 1 and angle 2. Okay? To find those angles, again, since the vertex is on the circle, the measure of angle 1 is going to equal to 1/2 of its intercepted arc. And how about we name that oops. Okay, so 1/2 of angle 1's arc would be arc ABC. And if I want to look at angle 2 over here, the measure of angle 2 is 1/2 the arc ADC. So what we want to note here is that if we have a vertex on the circle, we're going to take half of the intercepted arc. Here's this one's arc. If we have our vertex in the very, very center of the circle, then we're going to have an angle equal to its arc. Now, let's talk about another situation. What if we have an angle inside the circle? Well, I don't want that. I want a circle. Okay. What if I have an angle inside a circle, but its vertex is absolutely not the center of the circle? So I'm going to put a C here. Whoops. I'm going to put a C here because this is circle C. But I've got an angle formed inside the circle that is not on the circle and it's not the center. So it's going to be formed by two intersecting chords or two intersecting secants. They would form the exact same type of angle. So let me get a line here. So I'm going to put a secant through here. A secant is a line that contains a chord. I'm going to put another secant through here. So I have two intersecting secants, which of course also allows me to have two intersecting chords. And I'm going to name these angles. Oops, don't want to do that. I'm still learning. Okay. I could find any of those angles. Let's name these A, B, and X, Y. All right. Again, the vertex is absolutely, positively not the center. I could find any one of those four angles, and at your geometric sophistication, you would be able to find those other angles. If you knew angle 1, you could find angle 3 because they're vertical. If I gave you angle 1, you could find angle 2 and angle 4 rather, because they form a linear pair with angle 1. So you would just subtract from 180. So we need to know, though, if not given much information, how are we going to find one of those angles? So what we are going to do, ooh, boy, I made a big adjustment there, didn't I? What I want to do is talk about how to find one of those angles. And here is our new theorem. The measure of an angle formed, and we'll just look at angle 1 first. Inside the circle, I'm going to take 1/2 the sum of its arc. Well, angle 1's arc is AX. And angle 1's vertical angle's arc. Well, angle 1's vertical angle is angle 3. And its arc is going to be BY. So angle 1 is 1/2 of its arc and its vertical angle's arc. Now look at angle 3. Let's put those together since they're going to be the same thing anyway. Angle 3 is 1/2 of its arc, which is BY, and its vertical angle's arc. Well, its vertical angle is angle 1, and angle 1's arc is AX. So you see how these two are going to be the same? Addition is commutative. So we see that angle 1 and angle 2, or angle 3 rather, are going to work out to be the same. Now let's look at angles 2 and angle 4. The measure of angle 2 is 1/2 of its arc, which is AB, and its vertical angle, which is angle 4, its arc, which is XY. The measure of angle 4 would be 1/2 of its arc, XY, plus its vertical angle's arc. Its vertical angle is 2, and 2's arc is AB. So you just need to remember one formula, that an angle formed is 1/2 the sum of the angle's arc and its vertical angle's arc. If you can remember that, that little formula, then you could find any of those four. And once you find one of the four, you'll have all the others. Let's go on and look at some others. As we look at an example of the last rule that we just talked about, the last theorem, look at the guided practice 1A that should be on your screen. If we're to find angle X, the missing angle inside, and you can tell G is not the center of the circle, then I can say that the measure of angle X, or X degrees, equals 1/2 the sum of its arc. Well, its arc is 116. The vertical angle's arc is this arc that I'm marking here in black. Its arc is 47. So to find X, I'm going to take 1/2 of 163. X then is going to equal to 81.5 degrees. Perfectly okay that it didn't turn out even. Notice that angle X in 1B is not one of the angles that's affiliated with the 2 degree measures we've been given. We could take two approaches to this particular problem. One is to name the angle that is a linear pair with X degrees, Y degrees. Then we can find Y by saying that Y is 1/2 its arc plus its vertical angle's arc. So Y is 1/2 of 130, or 65 degrees. If Y is 65 degrees, then to find X, I would just need to take 180 and subtract Y to get X. So 180 minus 65 is 115 degrees. That's one way I could find the X value. Another way to find the X value is to remember that there's 365 degrees in the circle. 360 degrees in the circle, sorry. If there's 360 degrees in the circle, I can subtract the sum of 55 and 75. We've already said that that adds up to 130. All right, so 230 degrees would be the sum of MN and PQ. So X is 1/2 the sum of MN and PQ, and we just figured out that's 230. Now, we don't know into exactly what different measures they're divided up into, but we know the sum is 230, and according to our formula, the sum is all we need to know. So if we take half of 230, we can get our 115 that way. Okay, moving along then, on number 1C, we still have that interior angle inside the circle that is made when two chords cross. So the degree measure of that angle is 1/2 its arc. Well, its arc, one of them is unknown. Well, its arc actually is 154, isn't it? I got ahead of myself there. Let's make sure we get that right. I don't want to confuse anybody. Okay, the 128's arc is 154, and its vertical angle's arc is the x. So we can still solve for one of the arcs. This way, I would multiply both sides by 2 first. That would give us, what, 256? And then my 1/2 would cancel away. So x would be 102 degrees. So there's some examples. Okay, let's move on. Let's look at a couple of examples of the new rule that we had, where we have a vertex of an angle on the circle, but it's really not an inscribed angle. It's made by a tangent and a secant intersecting at the point of tangency. The question asks for the measure of arc JLK. So again, it's this little arc in here that's inside the angle measured 116. So what I need to do is just take my angle and double it. So JLK is 232 degrees, and I could easily, even though it doesn't ask me to, I could find KJ by just subtracting. Although this problem does not ask us to, we are probably going to see some that do. So the measure of arc JK is 128 degrees. And if I take half of 128, I get 64 degrees. And notice that 116 and 64 add up to 180, and that should be true. They form a linear pair. Moving on to 2B, we're to find the measure of RQS, the angle RQS. And notice part of the angle comes outside the circle. That's perfectly fine. If the measure of arc QTS is 238 degrees. Once again, we have 360 degrees in our circle. So let's subtract that 238 degrees. 122 degrees are left in arc QS. If my arc is 122 degrees, then I take half of my arc to get the angle. So half of 122 is 61 degrees. We've talked about how to find the angle measures if our vertex is on the circle. we just take half the arc. And if our vertex is in the center of the circle, our angle equals our arc. If we have two chords intersecting inside the circle, an angle formed is half the sum of its arc and its vertical angles arc. Now let's see what's happening if we have some angles that are formed by segments that are coming from the circle, but they form an angle outside the circle. So let's start that particular discussion by looking at what if we have two secants intersecting outside the circle. Now, secant lines are lines that contain chords, so I want to put in here two secant lines. So I'm going to come here. Let's do that again. Okay. Now, I'm going to name this point P for point. And then I'm going to label these points of intersection so we can use them. Now here, what I'm trying to find is what is the measure of angle P. P is an angle that is formed when two secants extend to the circle from the same exterior point, and that point in this case being point P. Notice that the angle, big angle P, or angle CPD, if you want to look at it that way, angle P intercepts two arcs. There are two arcs that are between the sides, little arc AB and then a larger arc CD. My angle is outside my circle, so this time my formula is going to be that the measure of angle P is equal to 1/2 the difference of the angle's two intercepted arcs. I like to use absolute value symbols because there are times when excuse me, some students may forget to put the large angle first. If you always remember to put the large angle first, you'll never have a problem and need the absolute values. But if you just happen to put AB first instead of CD, when you subtract those two arcs, you'll get a negative number, and you will need to take the absolute value of that number before you take half. So that's why I like to use the absolute value symbols. Again, if you always remember to put the big one first and then subtract the small one, you really won't have to. You can drop those absolute values. Now, what is so interesting about these three rules is that there are three that have the same formula, yet for different configurations. So let's look at a second one. Let's look at what happens if we have two tangents. Extending to the same circle from the same exterior point. So let's put two tangent lines on here. Okay, so here I have, let's put our point back out here again. We'll call this point P again, just for consistency. I just have one point of tangency there and one here. I've got a major arc and a minor arc, so let's label this major arc with a third point. I'm going to call it X. Now, once again, dolls, if you'll see this, my angle still intercepts two arcs on my circle. Arc AB, and likewise it intercepts arc AXB. So those are going to be the two angles that I'm going to be subtracting to find angle P. So to find the measure of angle P, I'm still going to take 1/2 the absolute value of one of the arcs minus the second arc. And I should have little measures on there. So it's the same rule, but one, you can see it works for if you have two tangents, and the other if you have two secants. Now let's think of another configuration that we can make in our circle, and I'm sorry my circle's kind of squatty, it's really an ellipse, isn't it? Another configuration that I could come up with on these is if I have one secant and one tangent, making the exterior point. So let's put those on. Let's come up with a secant line. Okay, secant is a line that contains a chord. And now a tangent line touches our circle at just one place. Okay, and we have again our point P out here. Here's our angle formed. So to find that little angle, the measure of angle P, I have to look for again the two intercepted arcs. Just noticed I left my absolute value off there. The two intercepted arcs for this particular angle. Okay, it intercepts arc AB, and it also intercepts arc CDB. So angle P is 1/2 the absolute value of the measure of arc CDB minus the measure of arc AB. Do you see how those are all the same formula, but for different configurations? Okay, let's work some examples. Let's make this a little bigger. I'm to find the measure of angle S. Angle S is made by the intersection of the two rays that are a tangent and a secant. So that tells me that the measure of angle S is going to equal to 1/2 the difference of the two arcs that fall between the sides of angle S. So I'm going to have 1/2 108. So my angle S out here, this little angle right here, is going to equal to 54 degrees. Okay, an example B over here. This time they have us looking for an arc piece. We're looking for this piece that I'm shading in green. Let's use our same formula. We still have a secant and a tangent extending to the same circle from the same exterior point of Y, and that angle is given this time. It's 68 degrees. So the angle formed is 1/2 the 224 minus this angle that we're looking for. I'm going to call it little a, since we don't have an a in that particular drawing. I like to multiply both sides by 2 first. That is not a have to, but just to avoid fractional issues that a lot of students have, we're going to multiply both sides by 2. So that's going to give us 2 times 68, 136, equals, and when I multiply the second side by 2, remember those cancel out, so the 1/2 is gone. Now, subtract your 224 and 136 there. When I do scrap work and I do it over to the side, I try to do it neatly and I save it so that if my teacher needs to see what I'm doing, he or she might be able to find what I'm doing, and there may be some partial credit that we can get in there. So I was talking, but if I did correctly, I've got negative 88 here equals negative A. So multiplying both sides by negative or dividing by negative, I'm going to find that arc XZ has a measure of 88 degrees. If you would look at it, guided practice 4 on your screen now, why don't you pause the video and see if you can work this problem, and then we'll come back and work it together and see how you did. You can pause the video now. Okay, let's see if we can find the measure of x. We have 2 secants extending to the same circle from the same exterior point. So the angle formed, which in this case we're being given, we're not asked to find it, we're being given, the 25 degrees equals 1/2 the difference of the 2 intercepted arcs. Well, the 2 intercepted arcs are the 110 and the x. So this is how we should have set up our problem. Again, I highly recommend you multiplying both sides by 2 to begin. That way you'll get your 50 over here and your 1/2 cancels away. Subtracting 110 from each side, we get negative 60 is negative x, or x must be 60 degrees. Did you get it right? All right, let's take a minute, pause the video, and work the 6 problems on your screen on page 745. Numbers 1, 2, 3, 4, 5, and 6. Pause the video, see if you can work them. Try to recall the formulas from your memory. If you can't and you need to go back and look in your notes, that's fine for now, but you need to be registering these in your memory. So let's pause the video now, and then you can come back and check your work. All right, we're back with number 1. We're asked to find the measure of angle 1. Angle 1 is an interior angle here. It's formed when 2 secants are intersecting inside the circle. We do not have a central angle because our vertex is not the center of the circle. So we're ready to use the formula that the measure of angle 1, which is what we're looking for, is 1/2 the sum of its arc and its vertical angle's arc. So we're going to take 1/2 of 134 plus 86. I believe we got 220 there. So half of 220 means that angle 1 is 110 degrees. On to number 2. This time we're asked to find the measure of arc TS. So we still know that the interior angle in there, that 126, is 1/2 of that arc we're looking for. I'm going to call it X, plus the vertical angle's arc. That's going to be 108. If I multiply both sides by 2, I'm going to get 252 equals x plus 108. And when I subtract 108 from each side, it looks like we're going to get about, what, 144? So the missing arc measure is about 144 degrees. Continuing and answering or asking ourselves, where is the vertex? The vertex is on the circle this time. So an angle formed is always going to be 1/2 of its arc. So I just need to take 1/2 of 146, and I'm going to find that angle 2 is an even 73 degrees. Okay, let's look at number 4. This time we're finding that exterior angle again. We've got two secants extending to the same circle. So angle H is 1/2 the difference of the two arcs. If I subtract 88 and 26, I get 64. I get 62. 62, sorry. Half of 62 is 31 degrees. So angle H must be 31 degrees. Number 5, we're asked to find this large major arc. So if I'm going to find that major arc, again, it is formed by a tangent and a secant intersecting from the same exterior point, which happens to be R. The angle formed, which is the measure of R, is 71 degrees. So 71 equals 1/2. The arc I'm looking for, let's call it Y this time. It's the big one, so I'm going to put that first. Minus 106. Let's multiply both sides by 2, so I'm going to get 142 equals Y minus 106. Then adding 106 to each side, Y is 248. Then last but not least on this page, we have again a tangent and a secant extending to the circle from the same exterior point. So that exterior angle, I don't know what happened to that. Okay, that exterior angle of 36 is equal to 1/2. Okay, this is the arc they're wanting us to find. Let's call it Z. 1/2 of Z minus 78. We're going to multiply both sides by 2. And we'll get 36 times 2 is 72 equals Z minus 78. When I add 78 to each side, I'm going to find that Z is 150 degrees. Sorry about squishing that in there. I hope you got those right. Let's look at the last problem that I had assigned for today, or for the next class, number 37 on page 748. Page 748 here. We're supposed to find a little piece of arc in here. This little piece of arc, X, is this measure right here. So we've got to find how many degrees are in that particular arc. What I like to do with this problem is set it up thinking I may have a system. I may not, but I see that I've really got a small circle and a large circle. So I'm going to make equations for both of those circles. Looking at the small circle inside first, I'm going to see if I can outline that in red so we can focus on it. And let's pretend the outside circle wasn't even there. So I've got the measure of angle A equals 1/2 the absolute value of the difference of the two arcs. Well, the two arcs are a 118-degree arc and a 54-degree arc. So I've got all the values that I need to find the measure of angle A. So let's go ahead and cipher, do the arithmetic. So we know that angle A is 32 degrees. Now with that information in mind, it's probably going to be a lot easier now for us to focus on the big circle, which is blue, and let's set up the same thing. That outside angle formed, angle A, now that we know is 32 degrees. And if we missed here, we're going to miss the rest of the problem, so be careful with your arithmetic. That 32-degree angle is equal to 1/2 the absolute value of the difference of its two arcs. So its two arcs are the arc that I'm looking for and the 79-degree arc. When I multiply both sides by 2, I need to subtract 79 from each side. That's going to give me negative 15 equals negative x, or x is 15 degrees. Okay? Good luck with this section, and we'll see you the next time.